Okay, so we have today's lessons here. I want you to pause the video now. I want you to take down all of the parts of this question. It's a tricky one today, and I suppose one of the most important parts that we're going to look at today is starting off a question, and then the last part here, finding directions. So how can I give directions if I was talking to someone on a ship? Okay, so today's lesson is going to look at angle of elevation, angle of depression again, but just taking it to that Leaving Certificate ordinary level standard, okay? So the question we have today is, a ship leaves a port A, okay, so this is our ship and this is the port. They're giving us some directions here. So it sails a distance of 4 kilometers in the direction of 30 degrees north. Okay, to a point B. The ship then changes direction and sails a further 6 kilometers in a direction of 60 degrees east to the point C. Calculate the distance from the ship's present position to point C. So it's at point C, find it to point A. So we're looking at going backwards there, right? Give your answer correct to 1 decimal place. So, we're looking at this question here and we have to, I suppose, try and figure out as much as we can. Now, when I look at a certain question like this, I'm trying to find out if it is creating a 90-degree angle or whatever the case is. Now, we can see here that this and this are perpendicular lines. So I'm zooming in here a little bit, okay, and trying to spot, I suppose, what information I'm given. So I am told that at this point here, this is 60 degrees. Now, I'm going to just extend out this line here just to try and see what I can see. So I'm extending that line out there, and then I'm going to also just highlight this A line here. Now what you can see there, hopefully, is you can actually see 2 parallel lines. And if you spot the 2 parallel lines, hopefully you're spotting the Z's. Okay, so we know that the Z's are, a real clear sign of finding some type of alternate angles there. So we know that this angle here is the same as this angle here, isn't that right? But likewise, if I was to draw my Z the other way, okay, so I have my Z going the other way, I would see that this angle here would be the same as this angle here. So this angle and this angle here are actually alternate and they're both 30 degrees. So I'm now going to just get rid of everything that I've drawn just to make it a little bit clearer. And I now know from spotting the 2 parallel lines that this is actually 30 degrees in there. I'm going to zoom in a little bit closer and write it a bit neater. So that is 30 degrees there. Now, what does that tell me? Well, if this is 60 degrees and this is 30 degrees, that tells me that this point here is actually a right angle. And then happy days, we know how to solve triangles with right angles. We can use our trig or we can use Pythagoras depending on what we're asking. But the issue with this question here was to try and make that a right angle. Like, how did I know that that was a right angle? So we would have had to extend, and now we have to explain to the examiner how we got that. So I'm going to call this just D here, just so that I have another point here. So I'm saying the angle DAB is equal to 30. So the angle DAB equals 30 degrees. And I'm also saying now that the angle ABE, now where is E? Let's draw a line down here so that this is E. Okay, so that the angle ABE is equal to 30 degrees, and the reason is because they are both alternate. okay? And then I'm saying to the examiner, okay, and I know angle, and I'll do it in blue, ABC, that one there, angle ABC is equal to now, if I zoomed in, it's the 30 degrees plus the 60 degrees, which is actually 90 degrees, which is a right angle, which now is going to help me much more in solving this question. So I'm going to draw the triangle as we would see it up there. And okay, I now know that this is 90 degrees. I know from here to here is 4, and I know from here to here is 6. And I'm asked, so that's A, B, C, and I'm asked to find C to A. And so obviously it is a right angle triangle here. And a right angle triangle, then what you can do with it is you can actually just do Pythagoras' theorem. So maybe if I drew it like this, it would look a lot nicer for people. So I have 4 and 6, and I don't know what the hypotenuse is. So I can do x squared, make it a bit neater. X squared equals 4 squared plus 6 squared. X squared equals 52. X equals root 52. And the question asks me to 1 decimal place, so I'm giving it 7.2 kilometres. Okay, so just really important there that with this question they didn't give us the right angle, we had to try and figure it out. So we're going back to our basics with geometry and trying to find those angles. So once we get started with a question like this, the rest will follow through and will be okay. Well done to anybody who copped that. That's quite difficult. But as I said, there's no point in us knowing how to solve all these triangles and how to do everything if we can't get started. And getting started is the hardest part. The next one, it says find angle BAC. So I'm going back now, I'm going to fill this in as 7.2. And I'm saying that this is angle B, A and C. And they're asking me to find angle BAC, so, or BCA, so they're asking me to find that angle there. Alright, so if they're asking me to find that angle there, I need to obviously, I'm finding an angle. The only way I can find an angle of a right angle triangle is by using sine, cosine and tan. So step 1, label. So I've got hypotenuse, I have opposite, and I have adjacent. And then step 2, figure out what I know. So I know that I have the opposite and the adjacent. So it's O and A. And if I look back, that would be tan. So I know the tan of the angle is equal to opposite over adjacent. So in this case, that would be the tan of the angle we don't know is equal to the opposite, which is 4 all over 6. And I want tan on one side, or I want the angle on one side, everything else on the other. So I'm going to do tan to the minus 1 on both sides. They're going to cancel. And I'm going to get theta is equal to tan to the minus 1, 4 over 6. And if I type that into my calculator, I'm going to get theta equals 33.69006. It says to the nearest degree, so 33 is equal to 34 degrees. Or sorry, theta is equal to 34 degrees. So that was the second part in that question. And the last one says, find the direction from C to A. Okay, so directions are a little bit tricky, but we've been looking at them for a long time. We've been looking at them since we were in primary school. So obviously it goes back to your basic compass, okay? And you have north, south, east and west. So we're asked to find the direction of C to A. So when you draw that triangle, what direction would you be travelling in? Okay, so we need to find the direction from C to A, which would essentially be, if I looked in, the angle CA, and this one here, I might call this one down here E. So if this is E here, we want to find the angle CAE. So this angle here, what would that angle down there at the bottom be? So let's fill in what we know from this anyway. So again, I'm going to just rub out all of this so that we can fill out the information. So we actually found what angle C was in the last part. So we know that this whole thing here is 34 degrees. Now, we also know up here we've got our two parallel lines, that this is 60 and we know that this is 30. But if we were to do our z's, we would know that then this one here is also 30, okay? Which means if I was to bring it down here and just look at this part here, that from here to here would be 30 degrees. Okay, now what that essentially means is if from this blue line up to the red line is 30 degrees, and we know that from the two red lines it's 34 degrees, we actually can conduce that this bit here is 4 degrees. And once you know then that the angle from here to here is 4 degrees, that's going to give you your answer. So it is 4 degrees. And what direction are we going? We're going in this direction here. So north, south, east, west. So north, south, east, west. So we're definitely going 4 degrees east, but we're going east north. So how we say that is we say east 4 degrees north. So we're going east, but we're going upwards when we're going east. So it's east 4 degrees north. That's how we give the direction there. So lots of learning in that question there. I want you to take your time, go through that from start to finish. Just in relation to directions, to just make sure that we're very clear, you can write them like this. So this is north 30 degrees east, which means in the direction I'm primarily moving northwards, but it's going to be 30 degrees east, okay? So that would be something like that. Whereas in the second part of the question, when we worked out our answer, we got east 4 degrees north. So that means I'm primarily moving eastwards, okay, but in a northerly direction by 4 degrees. So you can see here that just the difference in the direction. This one's moving eastwards, whereas this one is moving northwards. So whatever comes first is the more dominant direction, and the second one is obviously the less dominant direction, okay? So that's how you give directions, compass directions when asked.